Alright, so in this video and set of notes, we're going to be looking at the concept behind completing the square. So we're dealing with quadratics. And so let's look at this. So background information that is essential to this concept is that obviously if you have anything squared, it means that you're multiplying or times itself. Right? So if you have the binomial of the sum of x and 4 squared, that means you're going to do that, just that. You're going to multiply it to itself, the entire binomial, and each component multiplied to each component inside of it. Each term to each term. So you can use either what's called the FOIL or the box method or anything else to multiply these two binomials together. So traditionally I like to do my own version of the FOIL method, which is my inners and outers, and then I do my first and my last. So when you do this, one thing that's really important to notice about where they get the formula for completing the equation comes from this component here. Part of it comes from this component here at least. That when you are actually multiplying a perfect square like we have here, and the same number is multiplied to itself, well, when you multiply the inners, you get a said number, and when you multiply the outers, you get the exact same number. So when you add them together, no matter what it is, this answer here is equivalent to 2 times this original quantity of the inners multiplied together. And as you see here, 4. 4 times 2 would give you 8. So that is the same thing. We got a 4 by doing 8 divided by 2. We can use that math forward and backwards. 4 times 2 gives me 8. 8 divided by 2 gives me my 4. And so when we're working this process backwards, trying to get this missing number here, so we can get this missing number here, we have to first take our b here and divide it by 2 to get the value that was here. So kind of look that over, see what you have, and note that relationship of how, because these are the same, and there's 2 of them, this number divided into 2 equal values gives me this value here. Alright, so let's move on to the next piece. And so if you notice, the 4x divided by, or excuse me, the 8x divided by 2 gives me 4x. The 4 is in fact this last number in my binomial. So it is that number there. So what that means is you can rewrite this number here as b divided by 2. It is going to be the same thing no matter what this is. If you're dealing with a perfect square situation, this value here is always going to be the same as b divided by 2 because these are the same. And that's where this value here comes from in the completing the square formula. That finds that number in our binomial. Okay, so we come back to our original equation that we had up here that we got after multiplying the binomials. If you notice, it's the same equation, which means we can rewrite that as the multiplication of binomials of this here. If we were to factor it, this last value here is the same thing as b divided by 2. So if we go and actually start multiplying them and did our inners, did our outers, then we would have 2 times this quantity x. We did our first, we'd get x squared. And then here's the other significant part. When we go to do our last, it would be that number divided by 2 squared, because it's 8 divided by 2 times 8 divided by 2. It's multiplied to itself, which is the same thing as squaring it. And as you know, 4 squared is in fact 16. So that concept lines up. Down here, if I take 8 divided by 2 and times it by 2, those basically just simplify to the unit fraction 1. And I'm left with 8. So this can be written as this equation here, which then can be simplified as 8 divided by 2 is 4, 4 squared is 16, and so we haven't really changed the value of our trinomial. The only thing we've done is we took it, we broke it into 2 binomials, factored it, we then redistributed everything back and multiplied everything back, and then simplified back down. But the important part to note is that I didn't change the quantity when I used b divided by 2 squared for my c. And that's where they get the formula for completing the square, where c is going to be the value of b divided by 2 squared. And when you work it out, it comes out to be c. So go ahead and copy these down. I wanted you to make sure that you understood that they didn't just randomly come up with b divided by 2 squared. Why those numbers? Why that order? Why those values? And this is the reason why. Because it all works out in a perfect pattern, no matter which trinomial you use. If it is for a perfect square, then this relationship right here will always be true because of what we showed above. So when you go to complete a perfect square, this is what you're going to be doing. And if you're in this situation here, in order to keep the equation equal and balanced, whatever you do to one side, you have to do to the other, so that way you do not change the balance of the equation. And that is why you'll end up adding this c to both sides of the equation to keep it equal, and then start simplifying and solving from there, which we'll show in our next examples. But this is how you go about to set up the formula to solve using complete the square of a quadratic equation. And the steps to go about to solve completing the square. Mindful, there are a lot of steps, but overall the steps will repeat themselves over and over and over again no matter what. So once you have them down and get familiar with them, then it's just a matter of process of substituting in different numbers, and sometimes have to do a little extra steps in terms of the simplifying at the end. But let's see what these are. So make sure you head your notes so that way you can keep them all together. So we have our first example, and solve by completing the square is usually the term that you'll be. So you might see something that looks like this. And the important part to note is, like, I don't have a perfect square over here. If this is completing the square, then this should mean that this should be something I can factor into two binomials that are perfect squares of each other. But I can't do that with 51 because 51 is not a perfect square. So it doesn't belong there. It's kind of like an imposter. It's a book holder, imposter, whatever. It doesn't belong. That's not my true C. So because of that, you're going to want to use either the addition or subtraction property of equality to move it to the other side of the equation, to make room to put our true C. So once you've done that, you have your new equation over here. You want to identify B. And again, feel free to pause the video as needed as I move through it. So B, using our standard formula, is going to, in this situation, be 14. Once you have identified B, you're going to substitute into the equation that we found from the previous situation that C is the same thing as B divided by 2 and times itself, or squared. Right? So 14 divided by 2 is 7. That means that I could break it into my factors I'll see later on as x plus 7. And then C is 7 times 7, or squared, is 49. So we are going to rewrite the equation, but we can't just substitute in 49 here and that's it, because that will then offset my equation. So I need to use the addition property of equality and do it both sides with my value of C in order to keep this equation equal. So once I do that, I'm going to simplify. Right? And then I'm going to factor my trinomial on this left-hand side, remembering that this value here was the same thing as B divided by 2 from our previous page of notes. So B divided by 2 was my inner here, which was 7. So I can rewrite this as the multiplication of binomials of x plus 7 equals 100. Okay. So write as a square. So I'm just rewriting this as the square of x and 7. And now I can start to actually solve for x. Before, I was actually doing the whole completing the square, getting the C substituted in, and now I can actually solve. And I do that by taking the square root of both sides, because since that's squared, I have to square root both sides. And that gives me plus and minus. Let's move this up a little bit. Plus and minus your answer, the square root of your answer. And as from previous situations of how to solve using the square root, we now have to create two equations. We're going to create one equation with the positive of your answer and simplify. And then we're going to create a second one with the negative of your answer. So x plus 7 equals positive 10 minus 7 from both sides gives me x equals 3. And step 11 is to solve. And then I do my second equation was with a negative answer, a negative 10. So when I minus 7 from both sides, I get negative 17. So I rewrite my solution, which is 3 and 17. Okay. So that is one fundamental way that you're going to see these. The next set of notes are going to have shorter written notes here, and so you make sure you pause this and get these all down. Two. So I'm going to show you a different type that you might run into, and so that way you make sure that you know what to do in that situation. So again, step one, these are going to have simplified notes over here, but it's going to fundamentally follow the same basic steps, but rewriting them is a great way of practicing and studying the steps for yourself. So 59 is not a perfect square, so I use the addition property of equality to get rid of that false C. I'm going to identify B, which is 6. And step 3 says substitute B into my equation, which gives me my C of 9. Again, I am going fast, but you are welcome to pause the video and copy down the steps as we go. So I'm going to use the addition property of equality and add 9 into both sides of the equation and add it back into our equation. And I'm going to simplify. So now that I have my rightful C over here, I can actually factor, and remembering that this value here is B divided by 2. So if you're ever not quite certain, you have to remember, well, 3 times 3 gives me 9, 3x plus 3x gives me 6x, and x times x gives me x squared. So that's my multiplying of the binomials, or my factoring of my trinomial. So I then rewrite it as a perfect square, which means to solve, I need to square root both sides. So let's move our paper up. So now I'm going to start solving for x. And when you do that, you have to ask yourself, if you get something like here where it's not a perfect square, last time it was 100, which was beautiful, it was a perfect square, then you have to ask yourself, can that radical be simplified? And can it be simplified by dividing by a perfect square? So remember, our perfect squares are things like 4, 9, 16, 25, 36, 49, etc., okay?
Okay, go.
Into it, and the answer is yes. This can be simplified by 4. 4 times 17 gives you this value here, and it has to go in a whole number. That's what we're looking for. So now I can simplify by rewriting that as the multiplication of 2 radicals, and then I can take the square root of 4, which gives me, again, my plus or minus, and now I have 2 square root 17 over here. And so once we simplify, we're going to create 2 different equations. So now we're back with making 2 equations, one with a positive answer, one with a negative answer. So we created this using my positive 2 square root 17. I subtract 3 from both sides using the subtraction property of equality, and I get one answer. I create my addition, or excuse me, my subtraction version, subtract from both sides, and I get my second answer, and then I rewrite my solution. 3. So what you might come across is equations that look like this, that have the answer or has an additional number over here instead of a 0. And so this is going to show you how to go about to solve these type of problems. So 1, yes, 1 is a perfect square, but again, we're supposed to have it equal to equals 0. And we don't. We have minus 5. And if we were to add 5 to both sides, then we would have 6 for my C, which is not a perfect square. So either way, I'm in a situation where it's not going to work out to factor my trinomial, and I need to complete my square. So we are going to say that one's false. That's a false C, and we're going to use subtraction property of equality to move it over, and then identify our B. Once we've done that, we're going to substitute it into our equation for C, completing the square equation, and use the addition property of equality to plug it back into both sides. This should kind of start sounding familiar in terms of the process. Step 5, we're going to simplify. Step 6 is you factor, and remember that this term here is going to be from our b divided by 2. So in this situation I have negative 2. I rewrite it as a square, and then I can square root both sides to start solving for my x. So can the negative of square root 2 be simplified? And actually it can be, because we can actually write it as the square root of 2 times negative 1. And if you remember, the square root of negative 1 can actually be written as I. And that can thus be rewritten as x minus 2 equals plus or minus I square root 2. Right? So let's move this up. So from here, we're going to create 2 equations. Again, I'm just doing some shorthand of our steps. Our first equation is going to be the plus of our answer and simplify, and our second equation is going to be the subtraction. So I add 2 to both sides, and that is my answer. I cannot simplify that any further. That's my answer. So then I create my second equation with the negative. I add 2 to both sides, and I get my second answer. So those are my solutions. And I'm finished. So what you'll see is that the initial fundamental steps are all the same, but at the beginning, instead of a 0 that I added or subtracted from, I just had a value there that I had to add or subtract from. And then, since my answer here was a radical and the square root of a negative, I just had to pull out that I. And so, but the initial steps all were the same.